Today we're going to be talking about measuring in science. Particularly, we're going to be talking about the metric system. So in science, when we're talking about measuring, it's very important, but it's also very important in life. So when we talk about this, we're talking about things like, think about even science as being like cooking. If you don't get your ingredients right and you don't have the right amounts of ingredients, then whatever it is you're cooking, it's not going to come out right. It's the same thing in science. Just like when we're working on a project, we want to make sure that our measurements are right because you need the right type of tools. It matters what type of tools you use. You always need the correct size. Even when we're talking about our medications and things like that, we want to make sure that the pharmacist is measuring things properly so that we get the right amount of medication. So it's very important for us to be able to do the proper calculations and the proper measurements so that our results can be compared and everybody can understand them. And when we're talking about science, it involves problem solving. Math and science are a lot like peas and carrots, that line from Forrest Gump. They just go together. In order to problem solve, and especially in science, sometimes we need to use numbers and we need to use math. What we're going to talk about is a standard of measurement and why we need a standard of measurement. If I show you this is a picture of two horses. But when I say a horse, which one do you picture? The little guy or that big guy? If we're not clear on what a standard of measurement is, there could be confusion. A standard is an exact quantity that people can agree upon when they go to compare measurements. So think about this problem. You and your friend need to move a table, but you're not sure if it's going to fit into your trunk. What could you use if you don't have a tape measure or a meter stick or something to measure with? How could you quickly determine whether or not that table would fit? What could you use? Something you would have to agree upon so that you both could help figure that problem out. Historically, this has been a problem. Historically, horses were measured in hands, and the foot was the length of the person's foot. But there's a problem with this type of measurement. What's the problem? Why using hands and feet? Why would that cause a problem? Well, it would cause a problem because not everybody's hands and feet are the same size. So we need some type of standard, something that they share. So now we say that 1 foot equals 12 inches and 1 hand equals 4 inches. In science, to standardize things, we use the metric system. The metric system is used universally. The only place that it's not used is in the US. England uses both the English and the metric system. The metric system is used even in the US in science. It is easy to convert. It is universally used. It is based in tens. It is also sometimes called the international system, or formally the System International. So when you see that it's abbreviated SI, it is still the metric system going by another name. Let's do a little practice here. So let's match these up. We have A, gram, B, liter, C, meter. So when we're talking about measuring a 2-liter bottle of soda, it's a liter. It measures volume. That little packet of sugar, what do you think we would measure it with? It would be a gram. And that long measuring stick, that is a meter stick. These are the most common units. The basic unit for length is meter. The basic unit for mass is grams. In temperature, we can use Kelvin or we could use Celsius. Time is seconds. The other ones here we will not use in biology, so you do not need to worry about those. You do need to know these. You need to know that the general units for the SI system are meter for length, gram for mass, and liter for volume. In order to change these, what we do is we use prefixes. These prefixes represent multiples of 10. So the prefix kilo means 1,000. So 1 kilometer equals 1,000 meters. Centi, 1 centimeter equals 1 centimeter. 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 1 is 100th. So centimeter is 100th of a meter. 1 centimeter equals 100th of a meter. If we look at the metric system, there are lots of prefixes. Not all of these we'll need to know, but you really should know between kilo and milli. Kilo, hecta, deca, deci, centi, and milli. These can be added to the words meter, liter, and gram in order to tell us whether the measurement is getting larger or smaller. The metric system is always based in factors of 10, so it's very easy to convert. All we need to do is move the decimal point. What we're really doing is we're multiplying or dividing by 10. A millimeter is about the thickness of a dime, or about the thickness of your nail. There are 10 millimeters in a centimeter, and your centimeter is about the thickness of your pinky finger. So if you have a ruler at home that has centimeters, why don't you go ahead and see if you can calculate these. See if you can measure some of these using the meter and the centimeters. We use millimeters to measure tiny objects like your eyelashes or your fingernails. We really wouldn't want to use that to measure big things because it's a super tiny measurement. We use centimeters to measure small objects, meters to measure larger objects, and kilometers for large distances. So do you know what the English units are for the lengths above? What would we use for a large distance? What would we use to measure small distances? We would probably use inches, feet, and miles. We're going to skip over that one since you're at home and you can't do those measurements. Let's talk about volume. Volume is the amount of space an object occupies. A liquid's volume is usually measured using a beaker or a graduated cylinder. The SI units for volume are liters, kiloliters, milliliters, and centiliters. How you read a graduated cylinder. You read a graduated cylinder by reading the bottom of the meniscus. This graduated cylinder is reading at 23 milliliters. You can see at the bottom of the curve there. The mass of an object is not the same as its weight. Your mass varies from place to place. Your weight varies from place to place, and your mass stays the same. Mass is typically measured in grams or kilograms, but it could also be measured in micrograms or milligrams. You should recognize these two tools. We've talked about those before. You have an electronic scale and a triple beam balance. So when we're reading that triple beam balance, what we have to do is we have to read all three of those and add that up. So if you look where the little arrows are pointed, you're going to look at where those little arrows are pointed, and that's how we're going to read this. So when we look at this, what this is actually reading is this is reading 60 in the back, and it looks like it's not quite 2.5. So this would be 62.4 grams. So back to those prefixes. There's a few others other than kilo, milli, and centi. They are deci, deci, and hecto. When we remember these, the easiest way to remember this from kilo down is King Henry died Monday drinking chocolate milk. Take the first letter of each one in order to remember that. So, King Henry, kilo, hecto, died, deca, Monday, meter, deci, drinking, centi, chocolate, milk, milli. And as you see, these are all in base 10s, and as we go down, they get smaller. There's another look at that for you. We often use this step system. The step system helps us count. So if we move our finger along these steps, however many times we move our finger is how many times we would move our decimal point. Whichever way we move our finger, we move our decimal point. So what I would like you to do is I would like you to take and look at these questions, write these questions down on a separate piece of paper, or write them into a Word document and answer these questions and send them to me.